Right, we will be today looking at our Objective 2 packet. This is our homework for 21st, which is Tuesday, and 22nd, Wednesday of October. Looking at problem number 8. An athlete on the school football team. I begin by reading the question sentence. About how long did it take him to run for a touchdown? We're looking for how long it took him. We're looking for a time. An athlete on the school football team ran 20 yards in 2.9 seconds. During the last game, he ran for 64 yards. If the athlete's rate of speed remained the same, how long did it take him to run for the touchdown? Well, this is a proportional relationship. We're going to solve this problem using a proportion and cross-multiplying. I'm going to make a word fraction comparing the two quantities, yards and seconds. So I begin by writing that yards over seconds. This word fraction will help keep me straight whenever I make my proportion. Well, the first yards and seconds pairing is 20 yards took 2.9 seconds. 20 yards, 2.9 seconds. My numerator is yards, my denominator is seconds. We will have the same rate in the second part. It says the athlete ran 64 yards, so since that's yards, it'll go in my numerator. The denominator is what we're looking for, that is the seconds. And I'm going to use the variable t for time. You can call it x, you could call it any unknown that you would like to call it. Okay, so now I will be cross-multiplying. 20 times t yields 20t. 2.9 times 64. Well, let's go off to our scratch paper and do that multiplication. 64 times 2.9. 9 times 4 is 36. Carry my 3. 9 times 6, 54, and 3 is 57. 0 placeholder. 2 times 4 is 8. 2 times 6, 12. Summing 6. 5. Carry my 1. 5 and 2 is 7, and 1 is 8. And 1. 1856. There's one place behind the decimal, so I'll move it one place to the right. I have 185.6. Let's test for reasonableness. 64 is close to 60. 2.9 is close to 3. 3 times 60 is 180. That's close to that number, and that is definitely in the ballpark. Okay, solving for t, I will divide both sides by this coefficient 20. Dividing by 20 on the left and the right. 20 divided by 20 to leave t. Now I have 185.6 divided by 20. That's a 20 there. Let's try to rewrite that. 20. So, again to the scratch paper. 20 into 185.6. 20 divided into 185.6. 20 will not go into 1. 20 will not go into 18, but 20 will go into 185 9 times. 9 times 20 is 180. Subtracting the 5, bring down my 6. The decimal will go right above. 20 will go into 56 2 times. 2 times 20 is 40. Subtract and I get a 16. Bring down another 0. 20 will go into 168 times. So we have 9.28. 9.28 is my time, and that is measured in seconds. And 9.28 rounded to the 10th place is 9.3. Alright, next problem will be number 9. It says, which formula can be used to calculate the sale price? Well, the regular price here it says is 5. The sale price is $2.50. Regular price is 7. Sale price is 3.5. Regular price is 10. Sale price is 5. It looks like we're decreasing. In fact, it looks like each price is half of the previous one. So if we took our regular price and divided it by 2, we would get our sale price. If we graph these, we would see it's linear. It would also go through the value 0, 0, because if the regular price was 0, the sale price was also 0. What they're asking us to find in this case is the constant of proportionality. Hopefully you remember that the constant of proportionality, K, is equal to y divided by x. In this case, our sale prices are y, and our regular prices are x. Let's examine this first pairing. So K for us will be y, which is 2.5, and x, which is 5. Well, 2.5 divided by 5, that is 1/2. 2.5 goes into 2.5 one time, 2.5 into 5 two times. Our K is 1/2. So, to write our equation, it would be S equals 1/2 R. And 1/2 is the same as 0.5. So we see C here says S equals R times 0.5. Was it necessary to find our constant of proportionality? No. You could have found this answer simply by observing the pattern. Constant of proportionality. There may be a time where we do need to find the constant of proportionality specifically, but in this problem, we could have simply observed that from the regular price to the sale price, we simply divided by 2, which is the same as multiplying by 1/2. Answer choice C. All right. That's number 9. Problem number 10. Which of the following is closest to the amount of tip they want to leave? Okay, we have a percent problem. I'm going to explore this using our bar model. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right, so we have 10 boxes, each one being worth 10%. And I'm just going to indicate that's 10% the rest of the way. We need to find 10% of our whole. Our whole in this case, the entire amount, is $27.35. That's the cost of the dinner. All right. To find 10% of that number, I simply move the decimal one place to the right. So 10% of 27.35 is 2.735. Since we're talking about money, I'm going to round that to the nearest cent. 2.735 rounded to the nearest cent would be 2.74. 10% is approximately 2.74. All right, so that will go in each box, 2.74. 2.74, 2.74, 2.74, so forth and so on. Each one of these would be 2.74. All right, well, we want 20%. Well, 20% would be 2 10%. So, that's 10%. Well, that's 20%. 20% is 2.74s. That is 2.74 plus 2.74. Summing these two numbers, that's 8 7 and 7 is 4. Carry my 1. 2, 2, 4, it's 5. It's $5.48. And that is closest to $5.50. All right. Next is problem number 11. Number 11 is another percent problem. You will do it much like number 10 using a bar model. Number 12. Patrick drew, first I get to the question sentence. What distance on Patrick's map should represent the 1.5 miles between his house and the nearest gas station? Patrick drew a map of his neighborhood. He used a scale in which 1 inch equals 2 miles. 1 inch equals 2 miles. What distance on the map should represent 1.5 miles? So, we want to know what distance on the map in inches would be 1.5 miles. Again, we could employ a proportion. I'm going to start you with the word fraction, but then I want you to work the problem from there. Our word fraction should be inches and miles. Inches over miles. You should pause the video at this time and see if you can complete this problem, which is very similar to problem number 8. If you're not sure, review problem number 8. Pause the video at this time. Okay. Hopefully you completed the problem in this fashion. Inches, miles. Our first pairing is 1 over 2. 1 inch is equivalent to 2 miles in real distance. So we want to know how many inches. I'm going to call that x. Will be 1.5 miles. That will be my denominator here. Alright, this cross multiplication is nice and easy. 2 times x is 2x. 1 times 1.5 is 1.5. Dividing both sides by 2. X will equal, well, 1.5 divided by 2, 1.5 is like $1.50. $1.50 divided by 2, if I had $1.50, that would be 6 quarters. 6 quarters divided by 2 is 3 quarters. That's 75 cents. This is x equals 0.75. Let me see if we can verify that using the division algorithm. 2 into 1.5. Well, 2 goes into 1, no. So the decimal comes right above. 2 goes into 15, yes, 7 times. 7 times 2 is 14. There's an infinite number of zeros over here. 5 minus 4 is 1, bringing down my 0. 2 into 10, 5 times. 5 times 2 is 10. So we see indeed it is 0.75. And this 0.75 is my x, and x is inches. So x is 0.75 inches. We see the correct answer is A. Alright, number 13 is another percent problem. You should be able to do this using the bar model. So, complete the problems. Be prepared to submit it tomorrow in class.